Okay, I think uh, there has to be some issues with the scheduling. That's why I think no one has attended yet. But to maximize the time so that you can go back to the recording once you have time, I'll be moving forward with the discussion. So please use the time with John to ask any questions or to clarify things if there would be any. Okay, but here's Grace. Hi, Grace. Welcome to the meeting. You're the very first to join. I was about to start the session. Just I plan to record it. Yeah. I think the others are very busy. So, but anyway, it's nice that you are here. Okay. Okay. No worries. No worries. I mean, you can go back to the recording if ever you're also busy right now. So no worries at all. So yep, I should be starting now. Um, let me see. So sorry, it's Monday, still at work till 5:30. I'm in the new hospital now, and I'm in shared workplace. Yeah, sure, no problem. Grace, thanks for letting me know. It's perfectly fine. Um, yeah, I just want to maximize the time because I think we are um behind one meeting for the ideal schedule. So I think yeah, we cannot miss this session. So I have to move on and do the discussion. But if there will be questions, we can clarify that during the lab or during the recapitulation next meeting. Okay. So yep. So let's start ahead. I'm sharing my screen. Yes, sir. So the last time we started with a discussion about loops. So basically, the idea behind the loops is we want to reduce that need. Let me see, being presented on the other screen. Let me see. We want to avoid that issue of writing codes over and over again, just like what we saw or what we did when we had this example of the nested if statement. So one of our goals would be to write a code that is elegant, that is efficient. So we want to look for ways such as this loops in order to do that. Okay, so making it elegant is also means that it is more readable for other programmers as well. Um, Still not seeing a screen share. Yep, let me try it again. Okay. How about now, Grace? Just a thumbs up will do. If you can see it. Okay, perfect. So, yep, we discussed loops the last time, and this is called iteration. Okay, when we speak of loops, this is also synonymous to iterative computation. So we don't really need to write the same set of codes and change or tweak it a bit um, in the next line. We can do it in just one line through this loops. Okay, so we introduced two different kinds of loops, the for loop and the while loop. So we had a bit of discussion about the for loops the last time. Okay, so for the for loops, this is the structure. so, so we have the iterator and the sequence. Okay, so the iterator, it could have any name. So people typically use I for this iterator, but it can be any depending on your choice. It could be an actual word, or it could just be a letter. So the sequence could be just a single string. It could be a data structure. It could be a collection, such as those things that we discussed a couple of meetings ago. So it could be a list. It could be a dictionary. It could be um, what is the other data type that we? It could be a tuple. Okay, so you can iterate in those data structures. So with for loops, it would start from the very first item or object in your collection all the way up to the last one. So always remember that. Always remember this structure for iterator in sequence. Do this. So the process to be done is after this colon, and it's typically indented. So there's an indentation for the set operations to be done. Okay, after the line with the four. Hi Jeff, welcome to the meeting. Jeff says, "Hey Jeff, I'm at the airport waiting to fly around 6:14, so we'll have to drop off there." No worries. Okay, you can easily go back to the lecture. So I'll have John immediately upload this in our YouTube channel so that you can easily go back to it. And yeah, have a safe flight, Jeff, wherever you go. Okay. Yep. Moving forward. So So we had this example in which we have a collection here, skills, and we have the following objects inside it. So we know once we see the square brackets, so automatically we can easily identify this to be a list. So it contains five objects, or rather four, and we want to iterate. Okay, I want to print the objects inside this skills list one by one. So we are using a for loop in here that says that for iterator x in collection skills, do the process print x. So for the first iteration, it would be for the first object Excel, then the second would be for SQL, the next would be Power BI, and then the last one for Python. And the last time we also discussed how can we extend this? How can we add another skill, which is statistics? And there are so many methods in or with list that we can do exactly that. Okay, so here's the breakdown of each of the parts of the for loop in this example. So we've gone through this. So please interrupt me if you have any questions. So here, this is another example, but this time we are iterating through a single string object, which is the word chat GPT. So it's not necessary that you have a collection. It could be just a single value, such as this. However, we know that for strings, we can treat those characters as sort of objects in itself. So here we are doing a for loop that would also print each of the characters in the string ChatGPT. So this is essentially the same as what we did earlier, but this time we're just iterating through a single string instead of a collection. So here's also the background. We have the sequence to be looped through. We have the name of the iterator. It could be X, it could be whatever, and the set of operation in this case to print each of the elements in this string. Okay, and here I just give an example in which we can replace it with um, a letter I or any other letter. Okay. So we have this practice for the for loops. So we apply the loop. Again, this is just a printing for each of the string objects inside the list. And it is easy. So the main difference here is you have to sort it first because if you want to print it in alphabetical manner, then your list should be sorted first before you apply um, the loop. Okay, the loop of printing each elements. And we had this discussion about looping through a dictionary. So here there are several techniques that we have done. First is okay. If you just do it this way, what will be what will be printed, what would be manipulated in your for loop would be immediately the keys. So that's the default thing. Okay. So here we are iterating using the for loops in the topics underscore dict, which is basically this dictionary. And if you don't apply any method, you just apply it directly to the dictionary, it would just by default only apply it through the keys. So we discussed these two different methods in which if you want to loop through the values of a dictionary, then either we use the slicing method um, by using the square bracket, right? So we have the dictionary here and we are slicing by the iterator. So the topic here is the iterator. So it would access each of the values of our dictionary, or you can apply directly this method dot values um, that would allow the system to recognize, okay, you want to loop through the values only. Okay. And what if you want to use the or you want to loop through both the keys and the values? And we all know that in order to access both the keys and the value or the pair, you can use the dot items method for dictionaries. That would allow you to do this. But again, I've given you an example in which okay you can present this in a tuple form, which is more intuitive because you don't want to like separate the keys and the values. So it is better to present them in a tuple format. And we had this good example of what if we want to do a computation. In this example, we we develop a running total using the for loops, in which in every loop it would have a it would compute for a running total for each of this uh, items in our grocery list. So um, this is a basic but a very good example of how useful it is to utilize loops. You can do the same thing with a nested if statement, but it's very lengthy as compared to just doing it through loops, and it's more elegant and more efficient. So this is one version of the solution, but it's not the best. I think the last one that we did is better than what I have in here, and there are some aspects here that I failed to run. So the reason why it isn't showing here is I first run this part before the print, before I actually wrote this this print at the last. So the print here, this print empty print statement is um, actually not needed. So yeah, so you might be wondering why it's not being shown here. That has I haven't rerun it again together with the print function here, the last one. But we know we already know what this would do. So it will print this phrase, this string, and then this round function would round the decimal part of this grocery bill by 2, and then the separator would be nothing. So if you put any separator in between the quotation marks, that would be the separator between this thing right here and this value, the second value that you have. So uh, we stopped right there during the last meeting. So before I move on to a new topic, do you have any questions? Okay, hearing none, I think everything was clear. So now I'll be introducing to you a new concept. Okay, what if we loop through a range? Because typically, um, there would be times that you'll be given a range, right? Like say 0 to a certain value, and you don't want to put that or those numbers in a list form, right? There has to be another way. There has to be a better way aside from putting all of those numbers in a list or a tuple or a dictionary format. There has to be a better way. So it's not needed, again, it's not needed that you put each of the numbers from 0 to 50 in a list or in a data structure, okay, in any data structure. You can use the range function to say that, okay, I am starting from this number up until that number, okay? But there's a caveat. Similar to indexing, the value corresponding to the to the number that you have inside the range function would not be included. So that value, for example, you put range 10, 10 would be the limit. It would not be included in the loop. Always remember that. Okay. So let me go through this. So this is the structure: range, start, stop, and step, which is the same thing, with the same idea as with the slicing, right? So the stop value is not included. If the start value is not specified, it's the default is 0. Same as with um, slicing through the index. And the default step is 1. Okay. So let's have an example right here. Start moving. Okay. So I have here an example for using the range to loop. So for I in range 5, print I. So again, just like what I mentioned, so you can think of it as similar to the indexing. Exactly 5 would not be included. So think of it as a limit. Okay. So it will be excluded. So since we did not specify a start, the default would be run. So in this case, um, it would start from 0 up to 4. Okay, and the step is 1. So you can adjust the step if you want to get every other number you can assign to. So depending again on what you want to accomplish. So here we are specifying a start, so not necessarily 0. So for I in range 1 to 11, but 11 is excluded. So if we do that, if you run it, you would see that, okay, starts with 1 and ends at 10. Okay, so basic idea that we already know by now. You just have to remember that the range argument or the parameter of the range function uh, works the same way as with um, index slicing. So here we added the step. So remember that we're always starting with um, what we put inside the start function, or not function but the start um, position. Okay. So for I in range 2, you will be starting from 2 and you'll be having a step of 3. So there will be a difference of 3 for every step up until you reach 15, but 15 will not be included, so you have only 14 in here. So you start with 2 plus 3, that would be 5, plus 3 would be 8, plus 3 it would be 11, 11 plus 3 would be 14, and then that stops right there. Okay, so this is how you incorporate the idea of start, stop, step um, values in the with a range function. So let's have this practice. So create a list storing the letters of your name as elements. Use for loop to display each letter with its position in your name. So I just made this up. Of course, Raul is not my name. Okay, so I here a collection which I named letters, and I equated it to this objects RAUL. So that is for the first step. And then how would we see an output such as this? So the step would be just one because we're not We're not skipping any letter. Okay, and how do we position it? Okay, what would be the range or the value for the stop in your range function? So there are four elements here. So it could be, well, um, it could be, or it should be greater than that. Because if you just put four in here, then L would not be included. It should be the length of letters plus one, or in this case, five. Okay. So let's see the answer. So we have here initialization, defining the letters collection. We have Raul in there. And then we are setting up the loop for x in range, len letters, okay? Print letter x plus 1, letters x. So x plus 1 here, let's see. So for the x plus 1, So for the first, starting from the very first item, that is R. So it's actually updating this one. It's updating this number with the letter. Okay. So let's see. Let's switch to collab and try that. How do I separate this? Um, okay. I think you should see it by now. I'm For some reason the slide appeared on my third monitor, and I can seem to put it back on my second one. So yep. So let's have here um four loops with range. So we define letters to be a collection with R, A, um, U, L, and then we are looping through it for I in range len of letters print I. Okay. So for I, let me say len letters print letters. Um, I have a missing R right there. Row. Okay. Four. Yeah. Okay. So um, I think I mentioned something wrong earlier, that it should have a plus one in here, because if we start with zero with R, 0, 1, 2, 3, it should be four, but the length of letters is actually four. So we don't actually need to add plus one in there, length of letters. So this would give you four, and it starts with zero, so this is actually just 0, 1, 2, 3, right? So that's why we don't need the plus one in here. If we add the plus one in here, it would throw us an error that is out of range. Yep. So let's have that print, right? So we have an extra detail in our print, just like what you saw. So that would be x plus one, or I plus one in this case. and then I added here this, and then letter I. So this is actually a way to update the number because on the first iteration it is zero because it started with zero. So zero plus one would be one. Then for the next iteration, that would be one plus one. You'll have two, and then in the third iteration, you have two plus one, then you have three, and so on. So if we remove this plus one in here, you would see that it will be zero, one, two, three. Let me see the chat box. Hey Jeff, so John is not joining us today. Yeah, John told me that today is the schedule of their graduation pictorial. So I think he'll make up this week. He'll do some sort of a makeup um this week. Okay, great. And the others? Okay. So any questions regarding this, guys? Any questions? Or was it clear why we have a plus one in here to update the value in our print? Questions? Everything clear? Hi Hasiba, welcome to the meeting.
Hi.
Yep.
Sorry, I was late and I'm still outside. I'm going to home.
Mm.
So yeah, I can hear you now.
Okay, okay. Yeah, no worries. Um okay. So yep, I think everything was clear. I'm not sure. I don't see any response. Maybe just a thumbs up will be fine. Just to like have an idea if something is a um if it's clear or something's wrong. So again, yeah. Remember that we always starts with zero. We always start with zero. So um, if we don't update this by adding one, you will see that it would start with zero. And here we use the line of letters that is a range of four, but we only have three in here. So since we are starting with three, so it uses the index value. Okay. Thank you very much, Grace. Thank you very much. Just want to make sure that it's clear before I proceed to the next one. Okay. So thank you very much for that. Yeah. So that's the idea. Okay. That's the idea here. Nothing fancy. Just added some details in the print. So operations in for loops. So suppose we want to double each value in the list. We could do this individually. So here we initialized my nums. So my nums here is a list containing one, two, three. And now, what are we doing when we do this, guys? My nums, my underscore nums zero. So we are referring there to the first object in our list with the index value of zero. Why is it so? Because remember, a list is an ordered collection. Whenever a list or a structure, a data structure is ordered, we can make use of the index labels. Okay? So a tuple is also ordered, right? However, it's immutable as compared to a list that is both mutable and ordered. Okay? So we are accessing here. This is actually object recomputation. So for the first element, we are multiplying it by 2. Okay, we are updating its value. So that is 2 corresponding to whatever value or 2 times whatever corresponding value this index 0 is. So that is 1. So that is 2 times 1, 2 times 2, 2 times 3. That's why you will have 246 in there. Okay. Now the question is, um, how would we put it in a loop so that it would be shorter in a sense, right? Instead of doing it one by one, since as you can see, this could be presented in a range, right? We start with 1, we end with 3, exactly 3. So this structure can be set using a range function. So that's the way to see if something can be used or can be done in a range or with a range function and loops. Try to see first if it can be done, it can be presented using a range function. If yes, then um, you can do it through a range function with a for loop. So now let's see another example in which we are starting with 3 up until 7. Okay, so we want to double each value. So it's just easy. How? We are defining a for loop for I, basically for every element, for every object on this list, in range length of this. So this 3 has 0 up until that. So there are 5 elements, right? So this length would give you 5. So 5 would be corresponding to something that would be not included, right? So since this is 0 to 4, with respect to the index label, 5 would be something um, that is supposedly based on the definition of range will not be included. So always remember that length would always be greater than the number of elements, especially on ordered collection. I'm not sure if that was clear, but let me reiterate this. 3 here, okay? Let me reiterate that. 3 here is an index value of 0. This has 1, this has 2, this has 3 and 4. Remember, um, in our range function, we use to specify the end, right? Oh, it always does that. I'm not sure why. So if we say range 5, okay, exactly 5 would not be included. So it's sort of a limit. It's sort of something that would not be included in your printing. So if you put 4 in here, thinking that 4 represents 7, it would actually only include up until 6. Because if you look at the counting, this is 1, this is 2, 3, and 4. 4 is just for um, 6, right? However, again, um, the 4 would not be included. So that would be a problem for you if you want to include all of the elements in this list. Okay, do you follow, guys? So always remember that. Always remember that what goes in your range should be exactly the number of elements that you have in your list. So if you have 5 elements here, put 5 in your range. Okay. If you have 6 elements in your list, put 6 in your range. As simple as that. So that it captures everything. And the reason for that is um, it uses the index value, right? It uses the index value instead of the object count. Okay. So let me proceed through this. Let me delete or erase uh, okay, the scribbles I have in here. So we are defining here a for loop using the range. So for I in range length, my nums2, okay, just the count of elements. What we'll be doing in the process is this. My underscore nums2 I, what is this part, guys? What is this part? Okay, this part is object accessing, right? So when you do that, I is starting from what? What do you think? It's starting from the very first element. Do you follow? So that I actually starts at 0, which is corresponding to a value of 3. And what it does, this is object updating my nums2I times 2. Okay, we are multiplying each each element by 2. So in essence, we actually did the thing that we did earlier, okay? But using a loop. So in every loop, it would double the value of your object. So for the first loop, that would be 3 times 2. For the second loop, it would be 4 times 2. For the third loop, it would be 5 times 2, 6 plus 2, and then 7 times 2. So you would see that the resulting value would be 6, 8, 10, 12, and 14, which are twice of the values that you have initially. Okay? Questions, guys? Questions? Was it even clear? Hasiba, Jaff, Grace? So, as you can see, we are combining the ideas that we have learned from the very beginning, right? Defining a list, accessing a list, okay? Applying a for loop, and using this idea of the length function to double, okay? To double the value of each of the objects. So you might be thinking, Jeff, what if um, our sequence doesn't look like this? Meaning, it's like 3, 4, then 6, 7, 8. Can we apply the range function? Um, you can still apply it, but you'll be needing to delete that part in which is not included in your in your list. So meaning if you don't have say the number 5 in there, you can still use the range function, but you have to delete it um, before you present the final output. So it's one way, okay? It's one way, or instead just use the for I, right? For I in list, whatever, instead of using the range, okay? So you can only use the range, and you don't need the um any any deletion afterwards if it's a proper sequence such as this. Okay, a proper sequence. So we now apply conditions or conditionals in a loop. So suppose that we have a list of numbers 1 to 10. Again, this is the code, right? You have a list of numbers 1 to 10. It's a sequence, right? So that gives you an idea. I can use a range function here. And we want to print each number as well as whether the number is less than 5 or is at least 5. So that's that last phrase that we have, okay? So this phrase, um, starting from here, this is a conditional statement, as well as whether the number is less than 5 or is at least 5, okay? Less than or equal to 5. So that's the condition. So we would be printing, okay? We would be printing the statement um, less than 5 if the value is less than 5, and we'll be printing is greater than 5 or it's equal to 5 or greater than 5 if it's either equal to 5 or more. Okay, so we need to use an if else statement inside of our loop. So how do we set this up? So we have to first verify, is it possible that we create a range that would go from 1 to 10? So let's switch to our collab. So first create the sequence. And how do we do that? So say we want from 1 to 10. So we know that generating the sequence. It's easy to do that because the step is just one, the default. We just have to um, specify the start because it's not starting with 0, right? And the ending um, the ending index label. So that we have say range. So let's call this my range. So that would be range starting from, well, look at that. It already gives me the answer. Print my range. In this way, we'll have the thing that we need. Um, it's not giving me the entirety of things. Let me see. Mm, let me see. Why is it giving me that only? I was expecting to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me think. Range. Let me see. Um, Maybe what I want to do in here instead is I want to show you that we can print from the first item to the last, exactly this that AI is telling me to do. So in this way, we can see that it is from 1 to 10. So this is what we want, right? We want to have this set of values from 1 to 10. Now, after that, what we have to accomplish is we want to create a for loop in which there's a condition inside such that if the value is less than 5, we print a statement that tells that this value is less than 5. And if it's greater than 5, we also print a corresponding value such that I is greater than 5. So how do we set that up? So for we will be combining for loops with range and conditional statements. Okay, so we define that for I in range 1 to 11. Okay, um, no, we don't want that. But the structure it's giving us is the same. So if I, okay, which corresponds to the numbers from range 1 to 10 is less than 5, what do we do? Print that value, and then we add, this is just awesome. It's already giving me what I want to type. So I is less than 5. So when it encounters this, Else, if it's not, print I is greater than or equal to 5. And it's just amazing, right? It saves me so much time. So if we do that, we see that for the first four numbers, 1 to 4, it would be less than 5, less than 5. And then for the remaining, it's greater than 5. Okay. I may want to investigate what I clicked before. Because before I click that, doesn't give me this wonderful recommendations, very smart recommendations. And I think um, you should have it also because when doing the projects on the latter part of our Python sessions, that would save you a lot of time. But again, the important thing is at least you still know how things work and why things work. So use the AI as just a tool, but don't rely uh, rely too much on it. Okay. All good, guys. All good. All clear. Okay. Thank you very much for the response, and let's proceed with this. So as you can see, everything that we're discussing from the very beginning of the Python session up until this point. Okay, so there's a question here. Siba says, why it didn't count 11? Because with the range definition, the stop would not be included. So the value corresponding to 11 would not be included in the count. So that's sort of a limit, right? So always remember that what you put in the stop position would not be included. So for example here, if you want 1 to 10 values, you have to put 11 in here because if you put 10, it would only give you up until to 9, right? Up until 9, you see. Why is that so? Because remember that we're talking about index labels here. Yep. So although you have like 10 characters in there with index labeling, it would still be 9, right? Because we always start with 0. So you think about it that way, which is similar to how we discussed object slicing through ordered collection or unordered collection. So yep, I think everything's clear. Um, just for a while, minute. Okay. Um, yep. Sorry about that. Now we can proceed to the next parts. My intention for today is to finish the loops and then maybe we can start with functions so that in the next meeting we can start with Python for analytics, which is sort of the meat of the Python section. After we've discussed all of the fundamentals, um, we can now start accommodating data sets. Like how do we upload the data sets in Colab? What would be the first step in analyzing it? Okay, so I'll be showing it to you step by step. And what are some considerations because we don't want to be like a robot that follows just a certain set of steps, but we're not really understanding and we're not really considering the other options, right? Depending on the nature of the data set that we have. So always remember, there's no set of data. There's no sets of data that are the same. This data set that you'll be encountering in the future as data analyst, there would be uniqueness in each of them, and you should know how to handle them. Okay, there would be this steps that would be similar for each of the data set, but you should know how to identify the uniqueness and how to manage them. Okay, this different data sets that you'll be encountering, and yep. So this is the solution, which is basically uh, exactly the thing that the AI gave us. Okay, and then we have another practice here. So we have to write a program to display only the numbers from the list that are greater than 100. So this gives you an idea about the structure, right? So there's a condition. So there is a condition. This can be done using conditional statements, but assuming that you have a very large collection, it would not be very efficient to do that. So you have to do it together with loops. Okay? Can it be put into a range, guys? Can you use range here, the function range, to iterate through each of the elements of this list? Yes or no? You can just type it. I see Grace typing. I think Hasiba is on her phone, so she cannot type. Grace says no. Okay, with an how do you it's an interrogative question mark. Okay, yes, that's correct, Grace. It's a no. Why? Because it's not a sequence, right? You cannot put it in a sequence, or it's not a sequence, so you cannot put it in a range. So only the list that can be presented in a sequence format are what we can accommodate with the range functions. So it could be like 1, 3, 6, and so on. So there should be a pattern. So if you intend to use a range function, or if you're trying to find out if you can apply the range function, always use it as a filter. Can it be? Is it sequenced? If it's not, then just utilize the um, typical framework for the for loop. Okay, so we cannot use the range function here, to put it simply. It's not sequenced. Now, what condition, right? What condition should we put um, together with our for loops to filter those that are greater than 100? It's simple, right? The statement must be simple. If the value, okay, of your object, your element, is greater than the 100, you print it. That's it. So the system, once it sees your loop, your for loop, it would apply that. It would only look for all values greater than 100, and then it would print it. Okay, so let's, using that idea, let's translate it to codes. Okay, um, we want, maybe I would not give it a comment so that it doesn't know what I'll do, because I don't want it to spoil us with what should be um the codes that we need to write. Okay, so we'll be defining my nums. I'll just copy it. So it would be this list of numbers: 75, 150, 180, 145, 525, and 50. So we want to filter only those values greater than the 100 and print them. So for I in my nums, for I, again, the I depends on you. well, it's just too smart that it already gave me the thing. I just need to edit this greater than the 100, print, just print I don't need the other statement. So this would only look for greater than 100 and then print them, right? So we're expecting 150, 180, 145, and 525. Okay, so that's how we do it. Okay, I'm just amazed by how fast it recognizes, it predicts the thing that I would be writing. It's just crazy the technology that we have today. If you show this to like a programmer 5 years ago, it would blow up their mind because it's just amazing. It's just too good. Okay. Um. So that's how we answer that, and this is the way I did it before. I just added some details like there's the outer loop and there's the no no no. Where is that? I'm looking at the different thing. So yeah, I just did the exactly same thing. So we have here the nested loop. So this is the thing that I want to discuss. I think this is the last. This is the last. So um, this is similar to the idea that we applied with the if statement. Remember the nested ifs that we did. Um, most of the thing in programming can actually be nested. So it should be that the outer loop would be both the outer loop and the inner loops would be standalone. So they would be functioning on their own. Okay. Um, however, with the nested loop, the catch is the inner loop always completes before the outer loop. So think of it again as an onion. The inner layers would be the first to be run, and the outer loop would be the last one. So it starts from within um, in running the code. Okay, so let's see this. Oh, before that, let me read the final bullet. So for each iteration of the outer loop, the inner loop will complete its iteration for the given range, after which the outer loop can move on to the next iteration. I think that's not very clear. Although it's straightforward, we should have an example. Okay, so I have here an example num underscore list, which is a list, okay, of numbers containing 1, 2, 3. Now, for n1 in num list, then you see another loop. Okay, so this 4 is the outer loop, and this is the inner loop. So what we said was, let me just remove those drawings. We said that for each iteration of the outer loop, the inner loop completes its iteration for the given range. So the inner loop will finish first, right? It would complete all of the it would complete all of the application of the process or the operation to each of the element before it moves to the next object for the outer loop. As you can see in here, for the outer loop, it would be all one for this. One, one, one. Okay? So, however, for the inner loop, right, it would be one, two, three. One, two, three. So the inner loop completes its how do you call this? I'm looking for the correct word. It's completing its loop, okay, through each of the elements, starting from one to three. But for the outer loop, it's just for the first iteration, for the first element, for the first object in your list. So all of this, right? we are printing each of the values in our inner loop, it's 1, 2, 3. It scans through. It finishes first. Once it finish the loop, now the outer loop would be proceeding to the next sequence, to the next object. Now we have 2, 2, 2, 2. Why? Because for the inner loop, this is 1, this is 2, this is 3. So it finishes, okay? You can now proceed to the third object for the outer loop. So the last sequence, you have 3, 3, 3 for 1, 2, 3 in the inner loop. Okay, so this is what we say when we say that the inner loop finishes first before the outer loop. So it it scans through, okay, each of the object first in the inner loop. So there would be replications in your outer loop if you look at it this way. Okay, was that even clear? I think that's confusing, right? That's confusing, but it's intuitive because how can you finish? How can you finish applying the operation in your inner loop if you just skip together with the outer loop? If it would just finish at the same time with the outer loop, it would not be possible, right? It doesn't make sense to have that kind of process. So the inner loop would go through each of the objects. So every iteration of the inner loop would be the same iteration for the outer loop. So that's what you have in here. Okay. So let's have an example to better understand what's going on here. Let's have another example right here. So we have two lists here. We have the adjective, which is the ADJ. It consists of colors, sizes, and taste. We have the fruits, apple, strawberry, and cherry. So let's see what happens if we apply a nested loop in here. Okay. For X in ADJ, for Y in fruits, print X and Y. Okay. So for the first loop, what happens is, okay, the inner loop would be finished, would be done first. So for X, that would be for red. Okay. Starting with red. Then it would iterate through each of the fruits. So first with apple, then with strawberry, and then with cherry. Okay. So it would be applied to each of that element in your Y, in your fruits. Okay. Now, after that, we will proceed to the next one, which is in the outer loop, it would be big. Okay. So it would be big, and then it would iterate again apple, strawberry, and cherry. And then for the last one, tasty, it would then again be applied to apple, strawberry, and cherry. Okay. So that's how nested loops work. Always remember that. So how do we identify which comes in the outer loop and which comes in the inner loop? So it's in the definition of the loop. So what we have first in here would be the outer loop. So this is the outer loop, and what's inside would be the inner loop. So this the inner loop would be completed first. Okay, in that loop before you proceed to the next iteration in your outer loop. So think of it like that, like branching. With the first branch, you finish all of the roots before you proceed to the next branch, and then you would repeat that process as up to the last branch. Okay, do you follow, guys? Um, I'm not sure if I'm doing a great job here, but just let me know so that um, I can adjust. So let's see another example. Uh, just here, I just highlighted the thing that I just discussed. Let me I'm losing my pointer. Okay. So for the red, it completes all inside the inner loop. For the second object, the big, completes all in the inner loop before we transition to the next one, which is tasty. Then we complete the loop inside. So simple as that. Always remember that before you proceed to the next object in the outer loop, the loop inside must be finished first. Okay, so that's the only time that it would move to the next object in your outer loop in the next sequence. Okay, so here's an example, right? Print the elements of num underscore list that add up to 50. So always check first. Can we put it in a range? The answer is no, because it's like jumbled, like an arbitrary numbers, right? And we have here 50, and we're expecting 23, 27, 27 at the bottom, and then 23. Okay, so this is very challenging because it's kind of abstract, right? Yes, it's a combination, exactly. NCR, that is a combination. Okay, combination thing. So how should we first start in here? What would be our line of attack? Like our first step is very important because if we can establish our first step correctly, then the others would follow. If we establish an incorrect starting point, then everything that follows would be incorrect also. So both the sum of the first row and the second row must be 50, right? Um, in this case, it's just a matter of position. Just what Grace said. It's a combination. The position doesn't matter, unlike permutations in which the position and how the values appear matters, right? So 23 plus 27 results to 50, as well as the reverse of that, right? So what do you think is the first line of attack here? So um yeah, let's switch to collab, right? And so, well, it would give the answer immediately, I think so. So if n, let's first give the information that are present to us. You have n equal to 50, then you have the num list, which is a list containing 10, 20, 4, 23, 6, 18, 27, and 47. If I put here a comment regarding our goal, the AI would immediately give us the answer. So it would not let us think, which is not a good thing, right? So what we want to accomplish is to look for the combinations of the numbers in our num underscore list that would give a total of 50. So there are several ways of doing this. One way is to create a conditional statement, right? That whether the sum is equal to 50. So I think that's the easiest route that we can try. Like we would be defining two numbers here, right? So for the first loop, because it would scan through. Like if we hold this value first, 10, 10 plus 20, is it equal to 50? No. 10 plus 4, is it equal to 50? No. 10 plus 23, 10 plus 6, 10 plus 18, 10 plus 27, 10 plus 47. So that's what it will do. Okay. Then another way to think about it is if we have a sort of replicate of the num list 2 or the num list. We call it num list 1, which is exactly the same such as this. has the same objects. So you can think of like uh Grace, I think it if you type the comments in misspelled homophones, I think so. There's a chance that it would still recognize it. Um, we can try, but I think it's very smart that it would actually capture what we want to. Okay, so let me think. How can we do that? Um, uh, can you give me an idea to do that? Maybe like a statement, Grace. Um, we want to
Sorry,
see the.
can you
Yeah,
repeat that prompt?
sorry.
Can you repeat that prompt? Sorry. What
Yeah.
was the
Let me
first
go
step here
here.
in the nested loop?
Yeah, we
Is that what
want
you're asking?
to see the pairs, the elements that would add up to 50.
Okay. So you're gonna do if
Okay. If
x.
x.
Isn't there something after the x, after the variable?
Hmm.
Okay. So if x num list,
If x
and then
list.
num list one, yeah.
Okay.
And
If x
then the
pairs.
next line, so you have it num list one,
Okay.
and then the next line is gonna be indented because it's nested, right?
Oh,
If
you're giving me the solution, right?
sorry, that's why I didn't understand if that was what your question was.
No, no, no. I was asking the comment that you want to put here. And let's try if it can capture the thing that we
Oh,
want.
okay, okay. Then, let's also it would like we'd avoid the term nested loop and then
Okay.
put make combinations
Make combinations.
of
It will
lists
identify
to
this.
add up. It
To
did
add
it
up.
that fast
Make
to add up
combinations to add up
to
to 50.
50. Yeah, let's not even use the variable.
Okay. Let's see. Okay. Let's see. Um, yeah, I was earlier explaining the process, the idea that we can hold one value um, from numlist and add it together with the other and see if there would be a resulting value that is equal to 50. Or you can think of it this way that you have two numlist and just numlist one that contains
Oh,
exactly the same number, and you're trying to add each of the values or look for the combination, exactly what you said, that would result
should I
to
answer this?
50.
Was it more to? This would be my
Okay,
phone, but it's never got officially assigned. Oh,
great.
I'm sorry. That was the work thing.
Okay, okay, no worries. So let's see. So yeah, let's do that idea. Okay, that for I, well, there you go. It actually identified it, Grace. It's so smart. I mean, it's fairly smart, right? This is exactly what I have in mind is equal to num or to n, right? Print ij. Exactly. Print ij. Yes, this is it. Boom. Okay, I think I'm losing my job. No, just kidding. Of course, there are things that it cannot do. Still, especially the more um, deeper things. But here's the answer. I mean, it's very easy for AI to see to identify how to do it. Like just give it an idea about it, and it will give you the framework. But any question here? What happened with this code? So basically, there's two type of loops that's going on here: the outer and the inner. So for the inner, you can think of it as another num list, okay? And it's looking for whatever
So
value that you have in your outer list starting with 10. It would scan each of the each of the values that you have in your inner list and see if it results to a 50. So that would be 10 plus 10, 10 plus 20, 10 plus 4, and so on. So it would finish the iteration, okay? So each of the values in your inner loop, this j. So this is j, okay? This is j, and this is I. So for the first iteration in your outer loop, it will just be 10, okay? Plus n of this value. For the second iteration, it would be 20. Then 20 plus 10, 20 plus 20, 20 plus each of the values in your j, which is your inner loop, right? And then 4, so you will do it for each of the values in here. And then you have 23, which will get this 23 plus 27. That's why you have 23 plus 27 first. Okay? It would
yeah,
scan all
so
the
I have
way
a
throughout.
couple questions.
Yep, Grace.
So in your for statement, you have I in numlist and J in numlist. So you have them both in respect to numlist. So then what was the need to create numlist one?
No, I just did it just to show you what's going on under the hood, but it's not needed. I'm just showing you how the system is looking at it.
Is reading. Okay.
Yeah, it's reading it.
And then in the
So
AI
this is not needed.
stuff suggestions, yeah, it's not we're not needed, so we don't yeah.
Yeah.
Okay. And then for the AI suggestions, it probably would make those suggestions even without the comment, right? Based on what you've initiated
Yeah,
or initialization
it would still do it, but giving it an idea like this, like
via the
it's you
comment.
can think
Yes.
of it as a prompt. It would make it would make the suggestion even more specific.
And then isn't you can turn that off and then
Um,
a
you can
collab
actually
to turn off the prompting
let me think. If it's already built in the system, there we go. We can actually turn it off. Settings. Okay, now we can we can win ourselves from
hard
the
to
help
think.
of AI. So, but I'm not saying it's a bad thing, Grace. I'm not telling you to, but it's still here. Let me try reloading. In fact, in in Skillspire, we agreed that it's better for our students to be very familiar with how to use AI because companies are already looking for that kind of skill. So yeah, but it's this is difficult. Okay, let's be honest. Knowing how to do things and knowing why things work are completely different worlds. Okay, um, it's like comparing that you know things but you understand things. So for me, what I advocate to my students is it's better that you understand things because knowing it's not sufficient. It won't take you so far. So even though we have this AI, yeah, it would help you accomplish things. If it spits something that you don't know, it's your job to understand it first before you accept that it is correct or before you decide that you go with it. If it's giving you something that you're not familiar with, do your due diligence to study about that code, about that snippet of code that it has thrown you. Okay, so it's more about ourselves. Okay, how we can avoid being lazy of just um, following it blindly. Grace says, yes, imagine your surgeon following a step-by-step list on how to perform. Exactly, right? Um, but I think, yeah, it's just about you as a person. It's just about you. If you really want to call yourself an expert, then, uh, well, you have two choices to make. First is abstain, abstain using AI, or use AI with caution, right? Use AI with the mentality that it could give you errors, it could give you new things that you don't know, and it's your job to invest more effort to understanding how those things work, how those things that it gave you work. So again, it's about the person. It's about recognizing that there will be times such that you need to invest more effort to understanding it. So, yep, that's it for this example. Yep. So here's the answer, which is exactly like the same process that AI gave us. So was that even clear? Like how we came up with 23, 27, and 27, 23. Look at it row by row, okay? Don't look it in a column by column basis. So the output in this should be seen as, okay, this is output one, this is output number two. Okay, so this is one, output two. So you see this first matches a pattern in the 27 and the sort of other num list. That's why you have in here. And after that, you sees here and then sees the 23rd or the 23 in in the other num list you can take off. Okay, so that's it for this practice. Let's proceed to a new topic called while loop. So the keyword actually gives you an idea on how to use it. So while a condition is being satisfied, you will continue doing the operation that you have after the colon. Okay, so that's it. That's it for the while loop. And to me, while loop is very useful, more useful than the first two types of loops that we discussed. Because most of the time, it's better to just give a condition instead of going through each of the items, right? It's better to put it in a like a condition statement, in a condition form, conditional form, such as this. This is this can be done through the nested conditional statement and the for loops, but this is more elegant and this is more short as compared to that process. Can you give me, maybe we can take a 5 minute break, guys? I'll just get some water. Is that good? Uh, can we do that? Like a 5 minute break, quick break? Okay, so let's be back 9:42 my time. So, yep. Okay, I'm back. Sorry about that. I think yeah, I think I went over 2 minutes for about 2 minutes there. Apologies for that. Of course, Hasiba says, of course,
Right.
I'm still on my way home. Okay, keep safe, Hasiba. So, if ever you find something confusing when you go back to the recording, just let me know. I'm always online. However, the time difference is like 12 hours with the Philippines and Seattle. So there might be some delay in my response. Not some, but there's a significant delay probably. Grace, do you have questions?
What was my question? Question is, do you can you only discussion for 2 hours today, or are you able to go for three with John Don?
Um, I I intend to finish this discussion with loops. However, I will not be able to join you with a with a lab because I have to submit this papers as part of my job as a product manager. So, if ever you have questions regarding the discussion today or the assigned topics from John or assigned exercises, you can just keep it for now or keep them for now, and then you can clarify them with John tomorrow. I apologize. As much as I want to join you with the lab later, I have some tasks to finish.
Yeah.
Yeah,
No, it's
tomorrow.
don't worry. It's not like that. It's just knowing what to expect. Should I drive? Should I wait to
Oh,
be
okay.
driving home at 8 o'clock? Like that. Just trying
Yeah,
to
yeah,
plan my
you
day.
don't have to stay, Grace and Hasiba. You can do the assigned task if there are any, offline. Yeah, he won't be able to join, and I apologize
Yeah,
for
he
that.
said for today he wants
Yeah, he has, I think, graduation pictorial.
pictures.
There we go. There's John. I think he's still in the university. So that's how we'll do the
Where's this?
um let's see for his response. So anyway, I have to keep discussing because I want to finish this discussion with loops. So do you mind continuing, and then let's just figure out the setup later?
Go ahead. Yes.
Okay. So thank you very much. So um, let me define what while loop is. So the while loop keeps iterating over a certain set of operations as long as a certain condition holds true. Okay. So it operates using the following logic. While this condition is true, keep the loop running. So there is this caveat, okay, that there is a possibility of an infinite loop, and it will kill our computer. It will result to the crashing of our computer. So um, I will be giving you some examples of like infinite iteration. It happens sometimes. Well, oftentimes not intended. Of course, I don't think of any reason why you want an infinite loop. But in those cases, you have to kill your how do you call this? Your kernel, the kernel um in your Google Colab. Let me see. It doesn't show now the kernel. Let me try running this again. Originally, it was here, but now it shows Gemini. I think they're not really showing the kernel. Yeah, it doesn't show now the kernel. So the kernel is like um couldn't think of a term for it, but it's like a state in which it holds all of the information from the previous cells that you've run. So if you happen to like encounter an infinite loop, you can just click the stop in here. There's an option. There's a button to uh to stop the operation here, but sometimes it doesn't work, so you have to um just terminate the or restart the browser. Let me see. John says, "Hello everyone. Apologies today. I won't be able to meet you." Okay. How about on Wednesday? I think there's what is that holiday, Hasiba? I'll verify it in with the office. June 10th. Okay. Um, I'm not sure if it's a new federal holiday. I have to communicate it first with Yasmin, the CEO, and then let's see. There will be a new announcement that will be sent by Sherry. If there will be a holiday, then we have to extend the session again by a day, so that we can cover still the complete. But here in AZ, I don't have it off state, so uh, don't have it off. States decide what is recognized. Oh, I see. I see. So there's somehow like it's a discretion of the state whether they would recognize it as a holiday. Okay, got that. So yeah, let me verify it first. But most likely, if it's something new, I think it would not be a holiday. But let me confirm it first. Can depend on your employer. That kind of. I see. I see. It makes sense. So yep. Okay. So let's have an example for this while loop. So here we have a condition that says while the count is less than or equal to 10, you do this processes. First, print the count, and then update the count by adding 1, right? So you start with the initial value of count. This is again the initialization process. And then as long as this count is less than or equal to 10, this process would be done. Print and then update. Print and then update, print and then update until you reach a false. That is, in this case, a count that is equal to 11. Okay? Does this sound uh, clear, or is this intuitive to you?
I kind of understand that it count plus one relative to like its indexing, but can you repeat it again, like how it's coupled with the print and how it tells it to stop?
Okay, okay. Yep. So let me switch to Collab and create a different example. Okay, let me try to be creative here. Say age. We'll start age with say 1. Okay, the initialized age. So initialize age. Then what I want to do here is that while age is less than 18, I would be printing young, right? So that's what I'll do. So this is something related to our discussion of like um, the if statement, right? That if it's true, then you do it. But remember, with the if statement, you'll just doing it block by block. So if you want to do it for each of the values, starting from 1, 2, 3, and so on before 18, then there would be like 17 additional lines of if. So you can remove those nested ifs with the while loop, and it can accomplish the same thing with just 2 lines instead of 17 or more lines. So we initialized age. Now we say while, sorry for the indentation, while age is less than 18, what will I do? Print age. Okay, print age. Um, And I want to add is young. Just just additional details in my print, right? And then, of course, there should be a way to update the age. So this age plus equal 1, this is just equal to age equal to age plus 1. So we're updating the age by 1 every loop, okay? Every loop will be doing that. So for the first loop, for the first loop, okay? So for the first loop, the value of age is 1 plus 1. Okay, so you would see that the first printing would be 1, and for the before you start the second loop, it would add another 1. Because as you can see, the print starts here at first. So before you even update age for the first iteration, you will have a 1 in there, which is the starting value for a 1. Then for the second iteration, that's where the age should now be added 1. So the starting value for the next iteration for the age should be 2. And it would be first printed, right? So that would have 2 for the second iteration. So before you proceed to the third iteration, it would be updated again by adding 1. And for the third iteration, you print first before you update it. That's why you have 3. So we'd see that age will have 1, 2, 3, 4, up until 17. So when we run this, 17 is young, as you can see. So that's how the system is doing it. Okay, it's updating it after you have printed it. Okay, Grace, Hasiba. Okay, awesome, awesome. So this can be done with a conditional statement if, but imagine the length of that. Every block, every block would be needing a line of code. So this is very efficient. It accomplishes the same thing with fewer steps, fewer lines of code. So um, I have a question here. What would be the output for this while loop? So it's simple. What would we do is we try to understand each of the lines here. My num is initialized with a value of 2. Then we have the condition here, while num or while my underscore num times 2 is less than 50. So basically, the condition here is while the twice of my num is less than 50, it will do this process. However, there is also an updating that would happen for every loop, okay? For every iteration. That is the number would be increased by 2. So for the first printing, what do you think is the value that would appear? Exactly, perfect. The first value that would appear would be 4. Why? The initial value is 2, and then you multiply it by 2. That's why you have 4. And after that, the next would be the value of 2 would then be updated by how much? 2. Okay, so that would be my num is now for the second iteration 4, but 4 times 8 is what? Or 4 times 2 is what? 8. Is it less than 15? Yes. So you multiply it by 2. So the next iteration you will have 8, right? In your print function. Do you follow? And it would be added 2. So that would be 6 on the third iteration. 6 times 2 is still less than 15. Then print 6 times 2. That's when you have 12. So the answer is, oh, Grace says, oh yeah, for the last of, yes. So that would be 4, 8, 12, right? 4, 8, 12. Why we stop? Why we stop at iteration 4? Because 8 times 2 is now 16. And since it is now a false, right? 16 is not equal to 15. It terminates the loop. The while loop ends. So that's how we get 4, 8, and 12. Okay, so let's see it. Let's see it in action. It's better that we see it working, right? So we initialize my num equal to 2, and then, well, my underscore num times 2 is less than 15. Do this, print my num times 2, and update my num by 2. So this is, it looks like 4, 8, 12, which is exactly how we predicted. Um, okay, exactly how we predicted it. Okay, so this is just like a comprehensive discussion of what I just explained. So we already know the this thing, but I'll be giving you some time to look at it and ask questions. You might be thinking, okay, what is the significance of learning these things, Jeff? When our target is to analyze the data, there are very few instances in which you will be asked these kinds of things, of course, when you're analyzing an actual data. But oftentimes you'll be needing to update or manipulate the data, right? In those cases, you can use this this concepts that we are discussing. Okay. Yeah. So let's proceed. Okay. What would be the output for this while loop? I want you to think. I'll be giving you time to think on what would be the output of this. It's a very simple snippet of code. So what would be the output? Yes, that's true, Grace. This is an example of an infinite loop. So let me show it to you. So this is an infinite loop while why? Because y 1 equal to 1 would always be true. So it would run until you get tired or your computer gives up, right? Where was it? So it will just run forever. So how do you stop that? You can click on that this part right here, terminate the program. So what's the reason for that? Knowing the idea behind the while loop, as long as this condition is true, you will do this. And we know that this is forever true, right? That 1 is equal to 1. So it would run forever. So it's an infinite loop. Okay. Oftentimes it's not as simple as this because computations can be very complex and it's not very evident that you're running into an infinite loop. So it's nice to know that there is such thing as this that is called an infinite loop. In more complex computations, there is also something called convergence, and oftentimes, well, it's related to calculus. Oftentimes, the functions the function doesn't converge. So your computer could be looking for a potential solution, a very complex one. Uh, Suppose that you are trying to model a phenomenon, and it's looking for a combination of values that would explain the 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 phenomenon um, in the most accurate way, but it doesn't. It can find those values, so it doesn't converge. In those cases, you would have errors. There would be no solution to um, that problem, or it would give you an idea that another process would be more more fit in the phenomenon or in the problem that you're trying to solve. So we'll counter that once we discuss statistics. We'll be looking into some cases in which your solution might not converge, and so. But we will not, of course, we'll not be going back to calculus to discuss all those details. We'll just look into the practicalities. So here we have another practice. What we have to do here is to write a while loop that adds up all the numbers up to 10, including 10. Okay. So how do you do this? What would be the first step? Again, the first step is always the most critical, because it will your first step will determine your destination. Okay. That is true in programming, because if you fail to establish a good starting point, then everything will crumble down. You would be you'll have so much troubles midway. How do we do this? So I included here a hint. Start by making a loop that simply prints all the numbers, which is exactly what we did with the range. Then convert this program to make a cumulative total, which stores the sum of these numbers. So how do you think this would be accomplished? Just give me the idea, and we'll try to translate it into codes. Okay, so let me. So we have an expected answer of 55, right? So expected. Let's see if we can it can figure out what we want to do. Expected output is 55. So um, you want to add numbers up to 10. So basically, that would be we want 1 plus 2. Let's say 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, we want this. This is equal to 55. Now we want to translate that into a loop. How do you think we'll be able to accomplish that? And this is a tough one, right? But there's a pattern there. Does it keep printing? Oh, no, no. I thought this is a new message from Grace. What is the pattern that you were seeing right there? There's a pattern, right? It seems that what we're adding is just an increment of the first value, and it's an increment of 1. So if you think about it, we're adding one value, and there we are incrementing it by 1. on the next iteration. So if you start with 0, you can start two starting values, right? 0 and 0. The first one would be less than the other one. Yes, count equal 1, then count plus 1. Okay, so are you suggesting that we start with 1? If we start with 1, I have a feeling that the next value would be the first value that would show would be 2, right? So let's try that. Let's define a counter, right? Equal to 1, and then let's define a total, right? Look at that. While counter less than or equal to 10, total plus counter. This is the exact. It's okay. Wouldn't that be fine? So it loops in a way that likes Fibonacci. Exactly. Exactly. Right. So in fact, this is the correct answer. Even if we start with a counter of 0, it would still be the same because 0 plus 1 is just or 0 plus 0 is just 0. So 0 plus 1 would be the next value that would actually add something to the total. So that's what we have in here. And yeah, this is exactly what how I did this, right? Total plus counter, counter plus 1. This is for the updating. Okay. So this is for the updating the counter. But we want it to be like this. So the increment is just 1, which is basically the idea here. You increment it 1, and the total would be um, the total plus the counter. So this is equal to just, so this is just total equal to total plus counter, right? So for the first, it's 0 plus 0. And if we, let's see how it, how the values evolve, because I think it's important. And let's print the total on the last part. So you see right there, it's 0, 0, right? Then 1, then 3, 6, 10, 15. This is exactly like a Fibonacci sequence, right? So that's how you do it. That's how you do it. Okay. So it's awesome. It's awesome. I mean, um, first is recognizing a structure. You recognize that it's just an increment of 1 in every step, and we know that we can do that easily, right? Through this updating of values, and we can just get the total by stacking the values in a variable such as the total in this line number 6. So that way we'll be able to get the sum. Pretty awesome. Okay. So yep, let's proceed. So that's how we do it. And this is exactly how I did it here. And some supplementary practices. What would be the output for this loop? So we have a list. Anakin, Luke, Ray, Leia, Vader. For S in string list, if len is of S is less than 5, print len of S. So what would be it? So are we expecting a string? No, because len of S is a number. So A and C would be eliminated, right? It would be totally eliminated, A and C. So we only have, by process of elimination, B and D. However, we have a condition, it should be less than 5. But we have 5 in letter B. So the answer should be D. Do you follow? It's just a process of elimination by uh, um, arguing what we know. So if we look at it, it's D. It's 434. Length of S must be less than 5. S is the element. Okay, that's the iterator, each of the element in this list. So that's easy. How about this one? A for loop runs as long as its condition holds true. You might argue, Jeff, isn't it? Isn't it true? Because as long as it satisfies, just like here, as long as you satisfy, if you combine it with a conditional statement, as long as it satisfies the condition that you have, then it would continue running. Yes, so you might argue that my answer here is false. However, the exact definition that I have in here actually refers to the while loop. But you can argue again. You can argue that yeah, it can also hold true for the for loop if you consider it this way. You combine it with a conditional statement. But in itself, the for loop, what it does is it goes through the each of the elements. Okay, each of the iterator that you have. Do you follow? Can I get a thumbs up for that? Okay, thank you very much. So how would we replace the following for loop with a while loop? So this is a challenge one. So this original loop, this is the original. How do we change this to a while loop? This is actually easy, right? So we have the condition there. So we need to find that condition in either A, B, or C. Let's consider A. So we are saying here why I is less than length of the string list. If len of string list I object slicing, each of the elements is less than 5, print length string I. What's wrong with this? What's wrong with this is we don't have any updating. So it would only, this is not a for loop, right? So it will only consider I equal to 0, right? It would only apply to that since you're not updating I. So the loop would be only for an index value of 0 or Anakin. So A would not be possible. Okay, it will not run through each of the objects. So let's consider B and C because they both have value updates, right? We are updating the I, which is basically telling us you would be applying the length function through each of the elements. Let's consider B. Um, B says I is equal to 0, which is the initialization, while I length string list. Okay, if length string list I is less than 5, print length string list I plus 1. So we are starting with Anakin, with Luke. So that would be 2, 4, 6, 2, 4, 6, 6.
What is the difference between B and C that I'm missing?
Yeah, what's the difference? So what's the difference? What's the difference that you're seeing? Hasiba says, "Thank you, Jeff. I need to drop off. You're traveling from another." Okay, okay. No worries. Keep safe, Hasiba. Thank you very much. We're almost done. I think this is the last question that I have. So it's the difference between B and C that identifies whether which is actually correct. So with the updating of I, where is it located in B? It's it's outside if, right? It's outside if. However, with C, it's inside if, which is actually part of the conditional statement. So you're not updating it with C, right? It's part of the if statement with letter C. The updating for the while function to work should be outside the if, but still inside the while, right? So that's the major difference between the B and C. A, it's totally clear to us that it's not possible, but B and C, it's almost the same. It's almost the same with one very important distinction. B is updating it with the while function. So each loop in the while would update the I. However, it's not the case for the C because it's inside the if. Okay? So it will not be able to capture that in every update of the while. Okay? In every update of the while. So that's the major difference, and that's the reason why B is actually the correct answer. That is how we can transform the for loop to a while loop. But if you would ask me, Jeff, why would you transform it to while when you have for loop more elegant? It's just a challenge. But of course, in practicality, when you do it in actual work, the simpler process is still the most favored one. Okay, it's the go-to process. And just like that, we managed to complete the what I think the most challenging part of Python. The function is easy. Okay, after this, we have a discussion about functions, and that's just easy. Okay, so I made the practices here a bit more challenging to let you think. Again, the goal is from your ideas, transform your ideas into codes. Okay, I made those challenges, those exercises in that way. It's not just to to make your life miserable. Okay, it's to stretch you and um, develop, make you develop that ability. So thank you very much, Grace. I highly appreciate it. You're the last woman standing. Okay, so thank you very much, and see you again on the next lecture session. Bye bye.
I'll
Keep
see you
safe,
Wednesday.
driving
If
home.
not,
Yes, Wednesday.
otherwise message us, right?
Yeah, if not, then Saturday. If the admin tells me, let's have it as a holiday, then see you on Saturday. Okay. Keep safe, Grace.
Okay.
Bye bye.
Okay.
Appreciate it. Bye bye.